So hello everyone, my name is Johan Uruti. I'm the Director of Technologies for Spartacus, and today I have the pleasure to co-host that webinar with Mark Pinkerton from FluidLife. And this webinar is about how to get the most out of your vibration program thanks to oil analysis. So I am the Director of Technologies for Spartacus. I'm an engineer. I'm CMRP certified. I'm the creator of Spartacus APM, and more generally have close to 15 years of experience in the reliability world. Mark, you want to introduce
Hi,
yourself?
everyone. Hi, everyone. My name's Mark Pinkerton. I'm a senior account manager here at FluidLife. I've been with FluidLife for a while. My primary responsibilities are to help customers set up their oil analysis programs, and then also just provide continuous technical and administrative support just to make sure everyone's getting the value they expect from their lubrication analysis programs.
Very good. Thanks, Mark. So just a few words about Spartacus Technologies. We are partners in reliability excellence for more than 50 years, thanks through various partnerships. Mainly we focus on reliability services such as PM optimization, asset management, reliability assessment, and really the big R reliability world. And also we have world-class APM software called Spartacus to do asset health, digital round, lube rounds, etc. Mark.
Yep. And FluidLife, our primary business is oil analysis, analysis of a whole bunch of different stuff. So lubricants, coolants, fuels, filters, DEFs, even sludge that you might find at the bottom of a reservoir or something like that. Additional to that, we offer a bunch of certification-based training options, and also we have a reliability department. What we can do things like oil sampling program design, lubrication scorecards, audits, industry benchmarking, and we also have a service called Care, where you can hire us to look at your oil analysis results on a daily basis and just create work notifications and alerts whenever necessary.
Exactly. Mark and I used to work together a few years ago at FluidLife, pretty cool company and good memories for me. So with that being said, what is the agenda for today? Well, we're going to cover maintenance strategy based on failure mode. So really to set the context of that presentation, we're not just going to look at vibration analysis or oil analysis, but really as a whole, what there is to say about that. Then we're going to deep dive into oil analysis, how it's used, how to implement an oil analysis program. And then we're going to go back to the title of the presentation, which is how do oil analysis and vibration analysis complement each other, and finish up with a couple of case studies. So as usual, this aims to be interactive. You can type down some questions in the chat, or you can keep them for the end of the presentation. We'll have some time to chat and discuss or answer some questions, of course, if you want. But with that being said, let's go on and start with the maintenance strategy based on failure modes. So we'll start with a very quick poll. What do you think of oil analysis? And my friend Erwan, you're going to pop a poll on the screen. I do not see the poll at the moment. I guess I have to reopen that. All right. So what do you think of oil analysis? Is it essential, somewhat useful? It's a waste of time. What is oil analysis? I think it's an essential tool. And of course, that being said, we're able to see the results. More than 70% estimate that it's an essential tool. Some people think that it's somewhat useful, and some people think, well, what is oil analysis? That's great to learn that no one thinks it's a waste of time. So that's good news. So thanks everyone for your feedback. That's amazing. So with that being said, let's get going. So when we take care of our machines, which is our specialty and our passion at Spartacus and FluidLife, well, we want to look for symptoms of our machines, right? So symptoms like when you get the flu or a cold or even COVID, right? You want to look for symptoms, and especially what you want to look for is specific symptoms. You can look for common symptoms and something that is very specific to pinpoint and isolate what is your actual disease, right? So you can have some very common symptoms with regards to cold, flu, and COVID, like a sore throat or runny nose or a cough, right? But would you run a COVID test every time you have a runny nose or cough? Of course not, right? So you're going to have to look for very specific symptoms, right? Like a change in taste or smell, or even a loss of taste or smell, right? This would probably a bit more pinpoint towards COVID-19, right? So really, whether we're talking about vibration analysis or oil analysis, we need to go back to the symptoms, isolate them, and let them speak for themselves. So we always like to start with what are the symptoms or the failure modes of a gearbox. So again, we're going to run another very short poll with regards to that. So Erwan, if you want to bring that, thank you very much. And you're going to have a little text box to type down what are the symptoms or the failure modes of a gearbox. For example, I'm going to say it can leak. And you can type down as many as you want. The idea is to according to your knowledge and experience, how can you identify potential defects on gearboxes? Right, so we're seeing noise, heat, temperature increase, grinding, contamination, metal wear. Yes, very good. Very good. I see bearings. Bearings might be, very kind of very generic. What could be wrong with the bearings, right? So yes, backlash, excellent, excellent. Grinding. So yeah, a lot of very, very good answers there. And of course, in the reliability world and the world of engineering, this can be a very philosophical discussion. I feel like I always need to take a couple of drinks before engaging in such conversations about what are exactly failure modes with regards to consequences versus causes versus modes, you know what I mean? So, but very good answers. Thank you very much for participating in that. So going back to my presentation now, what are the failure modes of a gearbox? Here's a very short list of what I would consider being a list of symptoms for a gearbox: noisy, overheat, vibration, low oil level, high oil level, etc. And now the question becomes, okay, what do you do with that? Should we address all of these failure modes with specific, whether maintenance tasks, PM tasks, predictive maintenance tasks, with vibration, oil analysis, etc.? We don't know, right? It has to come back to the risk associated with each of these failure modes. So for example, you can look at the severity of a failure if not covered. For example, there's a high chance that if you hear a noisy gearbox, or if you have contamination, high contamination in a gearbox, or wear particles, in the end, it's going to damage the interior of your gearbox, whether it's your gears or a bearing or whatnot, okay? And so it will, thanks to criticality ranking, you may end up with a catastrophic failure of the conveyor or the pump or whatever asset that gearbox is installed on, which will in the end impact, production. Maybe it will shut down production for a couple hours because you'll have to replace the gear set or the entire gearbox or just the bearing, and so on and so forth, right? So really, not covering some of these failure modes may end up as a high severity. Same thing for probability of occurrence. You're going to look at what is the probability that that happens, right? And really what you're going to look for here is the history of issues, and you're going to ask your maintenance technicians, okay, what is the frequency that we're having low oil level or leaks, etc., right? And in the end, what it's going to give you is acceptable to an intolerable, sorry about that, risk. Right? So you can, maybe some of you have already done this exercise with a risk penalty number matrix, a 3x3 matrix, a 10x10 matrix. It doesn't matter. In the end, you end up with some failure modes that can be considered more risky than others if not covered. Okay. So with regards to oil analysis, of course, there's a couple of them here that are very interesting to us, and we'll get back to them a little bit later in the presentation. Let's go back to failure modes and failure systems, right? Typically, there are two types of failures, the sudden failures and the gradual decay failures, right? For sudden failures, you'll have either a constant mean time between failure, which will induce a maintenance strategy to replace before it fails, right? That's the scenario on the left. The literature tells us that that don't really happen very often. Probably less than 20% of all failures have a constant MTBF, which means that the rest is very random, like the scenario in the center, non-constant mean time between failure, which in the case of sudden failure, something we cannot see coming, will lead to run to failure. And then there's the last scenario, the gradual decay on the right, which will tell you need to monitor condition at optimal intervals. So if we look at chemical degradation, contamination, and wear particle, that falls under that category, right? Of course, it can happen to have a gearbox that suddenly fails because it was shut down and then it started back on with a high load because the conveyor was fully loaded when it shut down in the first place, and then you have a couple of teeth that fall apart, right? Of course, that happens, but most of the time it's going to be the scenario on the right. So we need to monitor at optimal intervals. Of course, looking at that graph and that trend, you may have thought, okay, well, that's the PF curve, right? So I don't want to spend too much time going into too many details with regards to the PF curve. You could refer to other videos we've made on the subject, but really, when looking at chemical degradation and particle counting, we're talking about the predictive and preventive domain with a medium interval before failure, right? When I mean medium interval, I'm talking in terms of weeks to month, in terms of before it fails. Right? The first time we're seeing some wear particles or chemical degradation, it means that in the upcoming weeks to upcoming couple months, there's going to be a failure, right? So that gives us a bit of time, but we need to take that into account and be careful. Mark, what is oil analysis and how is it used?
Well, that's a great question, Johan. I'm glad you asked it. And just like the previous sections, I suppose we'll start with a poll here. Mm-hmm. So before I start doing any explanation onto oil analysis and sampling and all that stuff, what does everyone think will affect the integrity of their oil analysis results the most here? So we got how the sample is taken, oil temperature, sample information, volume, or something else.
So put my answers in there. Let's look at the results. All right.
Yeah.
So 70% told us yes, it's how the sample is taken, which is very good.
Yeah. Sample information. Yeah, I mean that may affect the interpretation or how someone determines the real world criticality. Was the oil changed, yes or no, right? If you have oil that's problematic and flagged, is it still in there or was it changed out? Um, Oil temperature, I guess if you're, it can be, it can have impact, especially if you look at it as, is my equipment running or not? Is oil up to operating temperature? If you've let it sit overnight and it's cooled down,
Mhm.
you may be a bit more prone to have insolubles fall out of suspension, or debris that floats around during operation may settle to the bottom of the tank and not really show up in your results. Um, Sample volume, if you don't give us enough volume, obviously that's a good answer too. We won't be able to complete all the testing. So
Yeah.
yeah,
All right.
but
So
yeah.
so from what I understand, Mark, virtually all of the answers were good answers, right?
Yeah, good. You can make sense of all of them, but obviously how
Mm.
the sample is taken is going to impact the results the most, and we're going to
Yeah.
get into that a little bit here.
Very good. Thank you, Mark. Going back to the presentation, man.
Yep. So the first poll we did, we asked what's the usefulness of oil analysis, and one of the answers was, what is oil analysis? So we'll take a step back here and just go to the, super basics of what oil analysis is. So if you're completely unfamiliar with oil
Sorry.
analysis, it's a condition monitoring tool, just like vibration or thermography or ultrasonic or anything like that, except it's a tool that focuses more on lubricated systems, right? So grease, oil, stuff like that. Johan dived into it a little bit, but you're going to get some insight with oil analysis on the chemical health of your lubricant, contamination, so the nature of contamination, what it's doing to the oil health, etc. And then also the amount of solid particulate. So how clean is my oil or grease? When I'm talking about oil analysis to new FluidLife customers, or even just people who are interested in, what we do in the lab, the easiest way I can kind of explain and make a comparison to something else is it's essentially a blood test for your equipment, right? You're not going to just learn one thing when you do an oil analysis sample. Comparing it to blood, it might be, I'm going to figure out what my T cell count is, or my white blood cell health, or what my cholesterol levels are. So you learn a whole bunch of different things, but at the end of the day, it tells you essentially how healthy you and your blood is. If we focus on gearbox oil analysis, your typical results, here's the type of insight you can expect or that you should get for proper oil analysis monitoring. So a big one is going to be viscosity, right? A simplification of viscosity is how thick my oil is. The proper definition is what is the resistance to flow, and we measure that in cent-stokes. It can be as simple as just confirming that you have the right oil grade in use, right? If this gearbox calls for a 220. Do I got a 220 in there, or is it mixing with something else, or did technicians fill it up with a thicker or thinner gear oil? Oil analysis doesn't always have to be complicated. It can be pretty basic stuff like that. There's reasons as to why your oil would thicken or become less thick or thin out, I guess is a better term. And a lot of that can have to do with contamination, degradation, lube mixing. For spectrometry, this is where we focus on elemental concentrations. So we measure iron, copper, calcium, phosphorus, zinc, silicone, a whole bunch of different stuff. And that gives you some insight as to the total amount of wear metals, additives from your oils, right? So EP additives, anti-wear, antioxidation additives, that kind of thing. And then also contamination. Water content is a big one. In a perfect world, all oils would be completely dry. But in the real world, right, you guys deal with a certain amount of water ingress, whether it be humidity or straight up water getting into your equipment. So different concentrations of water will have different impacts on the health, long-term and short-term health of the oil. Oxidation, oils degrade chemically naturally. There's additives to try and slow down that process. But oil can degrade prematurely, and once it does that, it's more prone to be corrosive or to create deposits like varnish and sludge, or thicken up, which would have negative feedback on normal operation of your gearbox. We'll also measure acid number, which is the measurement of the concentration of those byproducts, right? Am I more prone potentially to have corrosive oil, or am I getting to a point where, deposits are a reality for me? And then one of the most important ones is particle count. So lubricant cleanliness, ISO codes, if you guys are familiar with that term, like how clean my oil is, what's the potential for me to create more wear because I have so much solid particulate floating around.
Good.
This is just a random oil analysis report I pulled from our database. We won't go in too much about specifics and how to interpret results, but just to give everyone an idea of what these report looks like. We do assign, flagging. We do try and help everyone determine criticality of the report, right? So it's nice to get these numbers here. And then where the rubber meets the road with oil analysis, just like any other condition monitoring tool, is if this actually merits some type of corrective action. So we'll give everyone some insight with flagging parameters, right? What are the industry norms? FluidLife has a large database of results from multiple customers from multiple industries. So we'll do stat analysis and we'll establish outliers, to give you guys some idea of where you stand versus everybody else. But what you want to do to determine criticality is, you want to trend properly. So are my results going up or down? Are they staying stable? Do I have any recommendations from my lube suppliers? Or even my gearbox OEMs? Did they give me cleanliness standards that is a hard stop? Yes or no? Also, asset criticality, right? Is this gearbox an auxiliary one with low oil reservoirs, or is this absolutely paramount to the operation of my mill or whatever, right? So all those decisions are going to impact what you do with the results and if any corrective actions are actually required. Yep. And then this is just a visualization of some of the graphs and additional trending tools that you have above and beyond those raw results there we saw on the previous page. And then, of course, Johan's going to go into it in a bit more detail, but you cross-reference your condition monitoring data as much as you possibly can, right? Oil analysis is a great tool, can tell you a lot of stuff, but it does have some limitations. So the more data that you have to cross-reference, the better decisions you're going to be able to make at the end of the day. In terms of getting an oil analysis program started or self-auditing one that you might already have in place, considering things like sampling locations and frequencies, it should definitely be reflective of what your goals are with oil analysis, right? We'll look at some general guidelines here, but I've decided I want to sample some assets. How often should I sample? Should I sample once a week, once a year? What should I do? For very large reservoirs where it's costly to change oils out, or your highest criticality assets, we would recommend anywhere between 1 and 3 months in terms of sampling frequencies. And then those frequencies start to ease off as your asset criticalities drop, or the size of the reservoirs get smaller, right? So think of it as, if I have a reservoir that's 5 liters, it doesn't cost that much money to change the oil on a regular basis. Well, I'm not too worried about, say, long-term oil degradation in that capacity. And then also, if it's auxiliary, if it breaks down, we have some, it's not going to interrupt operation, compared to, like I mentioned, your highest criticality gearbox or some lube system with 2,000-3,000 liters of oil, where costs go up with unplanned maintenance. Then in terms of locations, It depends what asset you're thinking of, but circulating systems, if you have one location to pick, it should always be on the return line before the filters. And then in non-circulating systems like gearboxes, you're probably going to have to use some type of fixed pitot tube or a pump and drain method. So you want to get somewhere in the bottom third of the oil level, as close to the actual moving components as you can without, damaging anything. But you want to stay away from that sludge line or the impurities line at the bottom there. That's not where we want to draw our sample at all.
Just one additional thought here, Mark. When
Yep.
when I told earlier about the PF curve, I said from the onset of failure to the failure, might be a couple of weeks or a couple of months. Well, this is where these typical frequencies is important, right? So 1 to 3 months intervals gives you the ability, if the real PF interval is 3 months and you sample every month, well, it gives you enough opportunities to see that, change and evolution of, debris or the contamination or the chemical degradation.
Yep. And then the other poll we looked at, what's going to affect my oil analysis results the most? I think the majority of you answered, how the sample is taken. So that's exactly right. Again, these are just generalities that we're talking in here, but the integrity of your results is directly related to how the sample is taken. And there's three main aspects of a good sample, right? What sampling tools do we use? Where was it taken? And when was it taken? So typically your tools, if you're lucky, you're going to have some type of sampling valve installed. For pressurized systems, it can be a push button or some type of check valve, which makes it easy. You don't have to open any reservoirs or stick any tubing in or anything like that. For gearboxes, there's these things called pitot tubes, which you still use a pump and tube with, but it still allows you to sample without inserting anything into the equipment through a breather or a drain or a fill cap or anything like that. The pump and tubing method, which we see on the picture here to the right, is probably what the most of you are familiar with if you've sampled before. This is using a suction pump to draw the oil out. Like I mentioned there on the last slide, you don't want to jam your tube all the way to the bottom. It doesn't happen every time, but it's pretty common where you might have some impurities build up there, more larger debris or sludge that isn't in circulation during operation. And we don't want that to show up in the oil analysis sample if it's not an accurate representation of the oil that's actually churning and lubricating and stuff like that. Then finally, the drain method is acceptable as well, as long as you don't take the sample when the drain plug is immediately taken, right? Again, you want to visualize that lower third oil level. So you'd pull the plug, let the oil drain out a little bit, and then proceed to take your sample. Sampling location, just think of it practically. Again, this isn't all rocket science, right? So how would my results change if I took a sample before or after the filters? Would they change if I took, if I took my tubing there and I just took a sample from the surface compared to directly on the bottom of a reservoir, right? And then time, again, we talked about it a little bit already. If you can take a sample when your equipment is running, that's ideal. Obviously, there's safety impacts and equipment running impacts and stuff like that you'll have to consider. If you can take it just after shutdown, that's the best. The oil's still at temperature. All of those suspended particles that are floating around during operation are still going to be in suspension. You want to prevent, or at least try not to take sample when everything's been resting for a while and all the debris is settled and stuff like that. So all of the different options you have are acceptable depending on what your goals are. But the main thing to remember is whatever options that you choose, you want to use those over and over and over again, right? Don't take one sample with a pump from the same asset and then the next time you use a valve or something like that. Oil analysis instruments are very, very precise. You might be surprised on the little amount of debris or whatever it takes to make a healthy report, a flagged report. So we want to limit the variability from sampling, the sampling process itself, when we're considering trending results. So that's the main message here is, establish a good tool, a good method, and then just repeat that over and over to the best of everyone's ability.
Good.
So the overall goal with oil analysis, it's the same. It's very in line with other condition monitoring tools. We want to set up our processes with oil analysis so we have good sampling techniques. We have the best tools available. We have high sampling compliance, so we're following our sampling PMs. We are completing the best testing out there to give us the results that we need to make good decisions. And once we have that all in place, we want to eliminate the fear of deciding on corrective actions, especially for unplanned maintenance. We want to eliminate that fear, and we want to have confidence in the results, right? So a lot of my customers, especially when they're just getting started, they'll see a flagged report. They'll tend to panic and overreact, but also not have the confidence to issue some type of corrective action. So they may take a resample. And there's nothing wrong with that. But at the end of the day, the whole goal is to identify problems in that PF curve before it's too late to do something. So as long as everyone has confidence in the process that they've established in terms of oil analysis, you should have confidence in the results as well, especially when they're severe and high ranked and flagged and all that stuff. So how do we implement an oil analysis program to address specific failure modes, right? So Johan mentioned it at the start. What is oil analysis the best at in terms of the various failure modes that you're going to deal with in a gearbox application, right? Oil degradation is one, whether that be premature or oils left in service for too long. Oil health. What's the chemical health of my oil look like? Contamination affecting lubricant performance. There's different options here, but we're going to focus on water as the main culprit. And then oil cleanliness, right? Is the amount of particulate in my the amount and size of particulate in my oil, is it leading to accelerated wear, abnormal wear? Is the contamination of solid particulate in my oil, is it normal? Is it expected? Is it abnormal? Right? So those are the three main things that we're going to focus on. There are other applications for oil analysis too. Again, it depends what your goals are. Some project continuous based goals you might have, let's say you drain your oils all the time and you notice that it's still a nice golden brown color. There's no smell. It's not dark brown or black. So you ask yourself, can I extend my calendar based oil drains? And yeah, oil analysis can help you support that. You can change to condition based oil changes too. So as long as my oil is chemically healthy, I have the ability to filter out my oil. Why not leave this thing going? Filtration optimization, lubricant consolidation. So I won't talk about this too much, but just keep that in mind if you have an existing oil analysis program and you're looking to use it for other potential continuous improvement projects. So if we focus on oil degradation, some common causes and effects here. So lube mixing, elevated temperatures, localized heating, water contamination, and catalyst metals. Right, so all of these more or less have to do with the thickness of my oil, its corrosiveness, and the potential for deposits. So thickness makes sense. Is my oil too thick or too thin? Is it actually resisting to the movement of my components, or is it not providing, the correct lubrication? And what is the cause of that? Is it my oil is shearing? Is it thickening due to oil progression of oil degradation and oxidation? All that kind of stuff. Elevated temperatures and localized heating is going to promote oil oxidation, so oil degradation. The rule of thumb is for every 10 Celsius above the maximum operating temperature of the oil, you're going to lose half of its life. So it's going to oxidize quicker, it's going to degrade quicker, it's going to thicken up, it might smell like eggs, it might turn a darkish brown or even black color. And when that occurs, you're going to increase the chances of your oil becoming corrosive, of varnish and slub deposits. So maybe a lack of functionality if you have, valves opening and closing, and heat dissipation too, right? You guys all know if we have too much deposits, one of the oil's job is to dissipate heat from the components. If they're covered and we can't make that heat transfer, that could be a positive feedback loop as well. So just a couple images for some visual aids, right? Corrosion. So water, if you have too much water, there's the straight up possibility of just creating rust in your reservoirs. Oil degradation, it can also be as simple as using the wrong oil type for application. So for any brass and bronze, like worm gears or anything like that, if you have the incorrect oil, the EP additives are too strong. It's just going to continuously corrode and eat away at your brass and bronze components. Lube acidification and acidic byproducts, right? Those are the deposits that we're talking about. I used a camshaft here. It's obviously not a gearbox, but this is just like a over-the-top visual of what I'm talking about in terms of deposits going to actually affect the proper operation of your components. And then sludge deposits, right? If you have lube mixing, all oils have standard oil additive packages. So EP additives, anti-wear additives, antioxidation additives. They don't play nice with each other sometime, right? If you mix a hydraulic oil with a EP gear oil, hopefully nothing really happens aside from thinning out an oil grade, but it's possible for the chemical reactions of the additives not to play nice with each other, and you can have sludge deposits and clog up filters and all that kind of stuff too. Contamination affecting lubrication. So we'll focus on water. I'm sure everyone has seen some iteration of the graph on the left. What's my expected bearing life with my standard water concentration in my oils. Water typically can exist in 3 phases in oils. Again, I mentioned we don't want any water at all, or as the least possible. Dissolved water, can typically be fine in an oil. Oils are designed to manage a certain concentration of water and not let it affect lubrication or long-term health. Once you start getting into that emulsified range where your oils can appear hazy or cloudy, that's when, water might start impacting the long-term health. It might overwhelm the dispersant additives and stuff like that. And then once you hit the free water range where the oil is completely saturated, you can actually start to see separation and layering in water and oil. At that point, you're more susceptible to a loss of overall lubrication. So if I have free water droplets, they could get in between my gear teeth as opposed to straight up oil. And even water, exposed to extreme immediate extreme pressure, you can have some vaporization there, and that can lead to cavitation and abnormal wear as well. So, water is not great. It's just one of the example of potential contamination affecting lubrication, but I'd say it's one of the more important when we're looking at gearbox oils. And then finally, contamination causing wear. So lubricant cleanliness is super important. Depending on what component type you're looking at in the environment of operation, obviously you may not ever have the cleanest oil, out there, but you want to try and limit the buildup of solid particulates. And it's just, it's a simple concept. You get debris, solid debris that gets in between 2 rubbing metal surfaces. The larger that debris is, the more likely it is to overwhelm the oil film in between those two contacting surfaces. And what is it going to do? You know, it's going to chip away at the surface. It might cause some fatigue due to lack of lubrication as well. So keeping your oil as clean as possible is going to try and prevent that positive feedback of solid particulate translating into more wear.
Excellent. Thank you, Mark. So how do oil analysis and vibration complement each other? So let's go back to our initial scenario, right? We talked about the failure modes. We identified some failure modes for a gearbox that can happen. So contamination, degradation, wear particles, and also vibration. So, and the reason why we focused a lot on gearboxes on that presentation is that you can do both vibration analysis and oil analysis on these type of assets, right? So that's why it was a good example. So on the next couple slides, I'm going to show you some analytic comparison. So these are data that are extracted from Spartakus APM, our software. So in that software, we have millions and millions of entries with regards to vibration analysis and oil analysis. So I took a deep dive for the past 2 years and extracted the most common failure modes captured with oil analysis within our software and the most common failure modes captured with vibration analysis in our software, right? And I'm presenting that to you. So the failure codes are the, and it's done in a standard way, right? So it's the same people in the same company that flag these issues, right? So it's very standardized, so you can easily trust that data. So of course, for gearboxes, well, the number one failure code with regards to oil analysis is contamination and particle count, right? So this is what comes out the most. With regards to vibration analysis, there's not a direct correlation between contamination or particle contamination and what you're going to observe in vibration analysis, right? Sure, you're going to damage the gears for sure. What might happen is that you can damage bearings on input and output shafts so much that you're going to end up with bearing defects, right? Which can in the end be seen here on the right. But mostly what you're going to be able to see as correlation is the wear on the gears, and how it's going to materialize is thanks to gear fault or looseness or bearing fault issues, or even maybe BPF fault, right? So it's really about assets degrading themselves and parts and components, right? Some of the steel, some of the copper material and the coatings of the rotating components are going to degrade, and you're going to be able to confirm that with vibration analysis and isolate where does that come from, right? Same thing for observations. So something that it's important to understand is that in Spartacus, you have the failure modes and failure codes, but in the back end, you also have observations by certified analysts, right? So I did the same analysis as the previous slide. And again, particle contamination, very, very high with regards to oil analysis in the gearboxes. And the rest would be a presence of water, a bit of viscosity change due to, we don't know exactly, but viscosity changed. And then we're talking about wear particles a bit below that, right? So again, you can confirm gear mesh frequency, with concentration of particles, right? Magnetic or non-magnetic particle, right? So again, I didn't want to go too much into the details there, but clearly what's very important is that if you have a standard way of reporting and analyzing oil results and vibration results, it's for sure something that's going to complement a good completion of the two technologies, right? If everything's at the same place with the same methodology and standard ways, you're going to have the ability to have better diagnostics and more complete diagnostics. And in a couple of seconds, I'm going to show you an example of what you can do when you have all of this data available simultaneously. One last word before we get to the case study is well, vibration data can be very sufficient to identify potential problems. So is oil analysis, but most of the time there is something that is that is lacking, right? So that's why having those two technologies working together might be very helpful. And so if I have to finish with the case study here, we have a piece of equipment in a pulp and paper mill, a customer of ours, that was showing gear mesh frequencies with the oil analysis, or our technician was seeing some weird frequencies, and we were able to find out that we were looking at a lot of material degradation with the oil analysis, right? So these two visuals, they come from our Spartacus software. Everything was in there, so it was very easy for the reliability engineers to pinpoint what the actual problem was, right? So it was there was a set of gears that needed to be replaced, right? So we were able to find that in advance, have the ability to plan and schedule the replacement of the gear set, and do it at the best time possible. And in the end, I believe we were able to save a couple $100,000 to our customers thanks to that complementary diagnostic. Mark?
Yeah. Yeah, and then the example I brought, again, it's just a pretty simple one. We work with customers in Canada and US, etc. One of the coal mines that we work with is underground, and their bottleneck is their conveyance systems, right? These gearboxes are typically in hard to get places. They've established a system that oil sampling is a little bit easier to take than, say, daily or routine vibe results or whatever. So what they've done is they've discovered the best practice for them is they take oil samples on a very regular basis, and they use that to monitor oil health and all the normal stuff, chemical degradation, all that stuff. But they also use it to try and identify when they start having bearing issues, right? We can see the Babbitt material start to present itself in copper and lead and stuff like that. And then we just switch here, Johan. Yep. I mean, they typically use that as a leading indicator, which will trigger them to say, okay, these gearboxes are in hard to get places, but the oil analysis results have told us, we should go do some vibration readings. And the reason for that is on an oil analysis report, it's great that you see copper and lead and they're elevated, they're flagged, but a gearbox might have a lot of bearings, right? So which ones in particular are becoming problematic or whatever the case is. So again, you just use, in this case, they use oil analysis to identify that there is a problem, and then they use vibration to pinpoint it, and then they're just able to optimize their maintenance response, or at least get ready for better prepared for upcoming maintenance. Overall goal is to disrupt production as little as possible.
Very good. Thank you very much, Mark. Thank you for those great insights. Thanks everyone for participating in that webinar. Again, I'm Johan Urruti from Spartacus. We have Mark, who's the Senior Account Manager at FluidLife. And well, we have a couple minutes left. If you have some questions, comments, or stories you want to share, well, feel free to ask.